Questions about variables can come up on any of your exam papers, biology, chemistry, physics, paper 1, paper 2. They can come up in any questions about an experiment or practical. Variables are essentially things that can change. Now, notice I said they are things that can change. I didn't say they are things that will change, just that they could. Now, there are three types of variables you need to know about in a science experiment. So, first one, independent variable. Now, the independent variable is the thing that the experimenter changes. The experimenter makes the decision to change it. They decide what values they're going to change it to. So normally the values they use are, nice round numbers. They might decide they're going to use 10 newtons, 20 newtons, 30 newtons, 40 newtons, if it's an experiment to do with force. If they're doing an experiment to do with temperature, they might decide they're going to heat the water to 5 degrees, 10 degrees, 15 degrees, 20 degrees. They could be doing an experiment where they have to take readings at certain times. So they might choose to do it after 1 minute, 2 minutes, 3 minutes. But the point is, it's the thing that the experimenter changes. There will be other things that change, but this is what they are deciding to change. Now, I'll show you a question that you could get on this. Now, notice this is a question with a big method at the start, but it's impossible to do it without reading that. What I'm going to do, I'm going to read through the whole method and I'm going to highlight anything that could change. I'm going to highlight all the variables. Then I'll work out at the end which one the independent is, because that's what I'm being asked. So, a student investigated the effect of pH on the rate of starch digestion. This is the method used. Add 2 centimeters cubed of amylase solution at a pH of 5 to a test tube. Add 2 centimeters cubed of starch solution to the same test tube. Start the timer. Remove 1 drop of the amylase starch mixture at 30 seconds and test the drop for starch. Remove a drop of amylase starch mixture every 30 seconds until no starch is detected. Record the total time taken for no starch to be detected. Repeat steps 1 to 7 using amylase solution at different pHs. The student kept all the solutions in a water bath at 37. Now, I've highlighted everything that could change. I mean, some of these things aren't changing. It says that they're keeping the temperature the same. It could change, so it's a variable, but they're not actually changing it. But for the independent variable, I need the thing that the experimenter is choosing to change. Well, that comes in step 8. Repeat steps 1 to 7 using amylase solution at different pHs. They are saying they are going to use different pHs. If I repeat the steps, well, I'm still going to use 2 centimeters of that. I'm still going to use 2 centimeters cubed of that. I'm still going to pick things out every 30 seconds. Still going to record times. That'll probably change, but I am choosing different pHs. So the independent variable pH of the amylase solution. It can't be temperature of the water bath because we're not changing that, so it's not the independent variable. And it can't be volume of starch solution because we're not changing that, so that can't be the independent variable. So the independent variable is the thing the experimenter chooses to change. Now, our second variable is the dependent variable. So we're no longer independent, we're now just dependent. Now, this will change. It will change, but I don't know what values it's going to change to. I know it's going to change, but I don't know what values it's going to be, so I need to measure it. Now, if I just go back to the previous example, I wasn't asked what the dependent variable was here, but there's something in here that's changing that I don't know what values it's going to be. That's my dependent variable. So in this one, it's actually total time taken. I don't know what time it's going to be, but it is going to change, so I would have to measure it. That would be my dependent variable. So we'll look at a question just focused on dependent variables. So I'll do the same again. I'll highlight any parts of the question that could change. So a student investigated the temperature change when different masses of calcium carbonate were reacted with hydrochloric acid. The diagram below shows the apparatus used. This is the method used. Add 50 centimeters cubed of hydrochloric acid to a polystyrene cup. Record the temperature of the hydrochloric acid. Add 1 gram of calcium carbonate to the hydrochloric acid. Stir the mixture. Record the highest temperature of the mixture. Repeat steps 1 to 5 with different masses of calcium carbonate. And we are being asked what the dependent variable is. Well, just pause. The independent variables thing I decide to change. Well, I'm deciding to change the different masses of calcium carbonate. So that must be my independent. Because I am changing that. I will decide how much calcium carbonate I want to put in. But the other thing that's changing that I don't know what it's going to be is the highest temperature of the mixture. And actually, what they're going to make us do is work out the temperature change. That's why we have the temperature at the start and the highest at the end. I don't know what that's going to be, so that's what I would measure. That's my dependent variable. So temperature change. Now, last type of variable is control variables. Control variables are things that could change that I'm choosing not to. I'm choosing to keep them the same to make it fair. So they could change, they're still variables, but I am going to actively make it so they don't change. So let's look at a question with these. Now, I've purposely picked a question that doesn't have a long method on this one to show you there's other ways to find the information. So we're asked to give 2 variables the students should keep the same. So we're being asked for control variables. So a student investigated the effect of different colours of light on the rate of photosynthesis. Figure 3 shows some of the apparatus the student used. The student placed the apparatus in blue light, then green light, then red light. The student measured the rate of photosynthesis. So, just recapping, they are choosing to change the colour of light. They've decided what the colour of light will be. So that's their independent variable. They're going to measure the rate of photosynthesis. I don't know how, it doesn't say, but we don't care in this question, but that's our dependent variable because they're measuring it. I need what they're keeping the same, and there hasn't been a big method to tell me. But there's some things here I haven't actually read yet. I've not acknowledged this diagram. This is here to help me. I want what should they keep the same? Well, they'd struggle to keep the number of bubbles the same, but they're probably counting those. So what they're going to have to keep the same is the time they count the bubbles for. So time to count bubbles. And there was my clue. There are always hints in diagrams, you must read them. Here's my second clue. So I would need to have the same amount of pondweed. Because if one thing had more pondweed, then it'd be unfair. There are other answers. So there are other answers that aren't hinted to that you could have had. If it says write 2, only write 2. But other answers you could have had could be brightness of light, which someone suggested in my lesson today. And there's probably other ones as well. So that's control variables, you keep them the same. Now, one final practice question. So this one, we're back to having a method, but it asks for 2 different variables, so I'm putting a few together now. So again, we'll read through it and then we'll have a look at the question. So a student investigated the effect of size of marble chips on the rate of reaction between marble chips and hydrochloric acid. They added 10 grams of marble chips. They added 50 centimeters cubed of hydrochloric acid and started the timer. Record the mass lost from the flask every 10 seconds. Repeat steps 1 to 3 with different sizes of marble chips. And then what we're being asked to do is draw one line from each type of variable to the correct example of that variable. Now, notice I've said draw one line. I do see a lot of people who feel like they need to connect up all the boxes. You don't. I am drawing one line from each type of variable. I've got 2 types of variables, so I should only draw 2 lines. So the independent, if you remember, is what the experimenter is choosing to change. Well, they're choosing to change the different sizes of marble chips. They are going to choose to use small ones, medium ones, bigger ones. So size of marble chips is our independent. Control. They're the things we keep the same. Well, we're always adding 10 grams of marble chips. So mass of marble chips. Nope, not one of the answers, so we'll keep going. Add 50 centimeters cubed of acid, so we're always going to add the same volume of acid. Yep, there you go, same volume of acid. Done. So variables questions can come up in any of your exams, biology, chemistry or physics. They're only normally worth 1 or 2 marks, but let's get those marks.